delivering quality education, expanding access to learning. The official TV-based instruction of Tagum City. This is Tagum City Division's DepEd TV. Tara na!
Your task today is to illustrate similarities of triangles. Before we start, prepare your paper and ball pen, and let's learn together. I have here 3 sets of pictures. The first set contains 2 boxes. The second set has 3 cans of milk. And the third set, black shirts with indicated sizes. What have you noticed on the characteristic of the objects in each set? Yes, you're right. Each set contains objects which have something in common. They have the same appearance or shape, but they have different sizes. In mathematics, we call them sets of similar objects. Now let us relate this to our lesson today about similar triangles. When can we say that triangles are similar? Let us go through the postulate and theorems on similar triangles. Take a look at this illustration. What have you observed? That's right. 3 angles of triangle ABC are congruent to the corresponding 3 angles of the triangle DEF. In the given illustration, we see that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. We use markings to show congruence of 3 angles of triangle ABC and triangle DEF. The illustration demonstrates the AAA or angle-angle-angle similarity postulate. This postulate states that if 3 angles of one triangle are congruent to 3 angles of another triangle, then the 2 triangles are similar. Since the 3 angles of triangle ABC are congruent to the corresponding 3 angles of triangle DEF, thus we say that triangle ABC is similar to triangle DEF. This symbol represents similarity. Let's have another illustration. What have you observed? Correct. 2 angles of one triangle are congruent to the corresponding 2 angles of the other triangle. In the given illustration, angle M is congruent to angle R, and angle N is congruent to angle S. This demonstrates the AA, or angle-angle similarity theorem, which states that two triangles are similar if two angles of one triangle are congruent to the corresponding two angles of another triangle. Since the two angles of triangle LMN are congruent to the corresponding two angles of triangle QRS, then we can say that triangle LMN is similar to triangle QRS. Let us observe this third illustration. What have you noticed? That's right. Three sides of one triangle are proportional to the corresponding three sides of another triangle. This illustration shows the SSS, or side-side-side similarity theorem, which states that two triangles are similar if the corresponding sides of two triangles are in proportion. In the given illustration, if side EF over side HI is equal to side FG over side IG equals side EG over side HJ, then we say that triangle EFG is similar to triangle HIJ. Let us observe this fourth illustration. What have you noticed? That is correct. The angle of one triangle is congruent to the corresponding angle of another triangle, and the corresponding sides, including those angles, are in proportion. In the given illustration, angle M is congruent to angle Q, and LM over PQ is equal to KM over OQ. This illustration shows the SAS, or side-angle-side similarity theorem, which states that two triangles are similar if an angle of one triangle is congruent to an angle of another triangle, and the corresponding sides, including those angles, are in proportion. Since angle M is congruent to angle Q, and LM over PQ is equal to KM over OQ, then triangle KLM is similar to triangle OPQ. To sum it up, we have AAA similarity postulate, AA similarity theorem, SSS similarity theorem, and SAS similarity theorem. These are the postulate and theorems on similar triangles. When can we say that triangles are similar? Yes, we can say that triangles are similar if their corresponding angles are congruent and their corresponding sides are proportional. Now let us identify whether the given pair of triangles are similar or not, and write a similarity postulate or theorem such as AAA similarity postulate, AA similarity theorem, SAS similarity theorem, or SSS similarity theorem that demonstrates the similarity. Number 1. We have here triangle EFG, where the measure of angle E is 42 degrees and the measure of angle G is 40 degrees. And another triangle XYZ, where the measure of angle X is also 42 degrees and the measure of angle Z is also 40 degrees. Are the triangles similar? Yes, they are. Triangle EFG is similar to triangle XYZ. What would be our similarity postulate or theorem? Correct. AA similarity theorem. Why? It is because in the given illustration, the two angles of the triangle are congruent to the corresponding two angles of another triangle. Angle E is congruent to angle X, and angle G is congruent to angle Z. Number 2, we have here the first triangle, triangle ABC, where angle B measures 53 degrees. Side AB measures 6 centimeters and side BC measures 9 centimeters. We have here also the second triangle, triangle PQR, where angle Q measures 53 degrees. Side PQ measures 12 centimeters and side QR measures 18 centimeters. Are the triangles similar? That's right, they are similar. What would be our similarity postulate or theorem? Yes, SAS similarity theorem. Why? It is because in the given illustration, the two sides of one triangle are proportional to the corresponding two sides of another triangle, and their included angles are congruent. Angle B is congruent to angle Q, no problem with that. Side AB over side PQ is equal to side BC over side QR. To show this, we substitute the given lengths of sides to the equation. We have 6 centimeters over 12 centimeters is equal to 9 centimeters over 18 centimeters. The units of measure are cancelled out. Then we reduce the fractions to their lowest terms, giving us 1 over 2 on the left side of the equation and 1 over 2 also on the right side of the equation, which proves that the corresponding sides of the triangles are proportional. Thus, we say that triangle ABC is similar to triangle PQR. Number 3, we have here triangle JKL, where side JK measures 21 inches, side KL measures 12 inches, and side JL measures 15 inches. We have also triangle XYZ, where side XY measures 7 inches, side YZ measures 4 inches, and side XZ measures 5 inches. Are the triangles similar? Correct. Triangle PQR is similar to triangle XYZ. What would be our similarity postulate or theorem? That's right, SSS similarity theorem. Why? It is because in the given illustration, the three sides of the triangle JKL are proportional to the corresponding three sides of triangle XYZ. JK over XY is equal to KL over YZ is equal to JL over XZ. Let's show this by substituting the given lengths of the sides to the equation. We have 21 inches over 7 inches is equal to 12 inches over 4 inches, is equal to 15 inches over 5 inches. We simplify further. The units of measure are cancelled out, and we reduce each fraction to its lowest term, leaving us with 3 equals 3 equals 3, which proves that the three sides of triangle JKL are proportional to the corresponding three sides of the triangle XYZ. Thus, triangle JKL is similar to triangle XYZ. Number 4. In the given figure, we have the first triangle, triangle ABC, which has angle A that measures 58 degrees, angle B which is 59 degrees, and angle C 63 degrees. We have the second triangle, triangle DEF, with angle D that is equal to 58 degrees, angle E equals 59 degrees, and angle F 63 degrees. Are the triangles similar? Yes. Triangle ABC is similar to triangle DEF under AAA similarity postulate. Why? It is because in the given illustration, three angles of triangle ABC are congruent to the corresponding three angles of triangle DEF. Now let us check if you understood the lesson. Identify whether the given triangles are similar or not, and give the similarity postulate or theorem. You are only given 3 minutes to answer. If you hear the sound, it means time is up. Are you ready? Time starts now. All right, time is up. Let us check your answer together. The answers are: number 1, similar triangles under SSS similarity theorem. Number 2, similar triangles under AA similarity theorem. Number 3, similar triangles under AAA similarity postulate. And number 4, similar triangles under SAS similarity theorem. How many correct answers did you get? If you got 4 out of 4, congratulations. If not, try harder next time. And that ends our 6th math episode in Salida La Filipina TV. Once again, I am Teacher Bernabe A. Sinabre saying, if math is hard and so is life, then get over it. Have a good day. Bye-bye.
Salida la Filipina, ang iyong pangarap ay kikislap. Salida la Filipina, ang kaunungan ay magkakuntat. Salida la Filipina, edukasyon, abot kamay. Salida la Filipina, ang tagatangay sa tagumpay.
Mga kabataan, huwag panghinaan. Salida la Filipina ay bigyan daan. Ito ay magbibigay ng kaalaman. TV naman ngayon ang inyong paaralan. Mahirap man ang inyong sitwasyon, tayo ay magtulungan para sa edukasyon. Bawat isa ay mayroong misyon, matutong mabuti, maging inspirasyon.
Salida la Filipina, ang iyong pangarap ay kikislap. Salida la Filipina, ang karunungan ay makakantan. Salida la Filipina, ang edukasyon, abot kamay. Salida la Filipina, ang gagabay.